Okay, so page 4 is explaining to you the concept of domain and range, or it's going to start introducing domain and range. Basically, all you need to know is that your x and y values make up domain and range. So xy, xy, xy. So domain are the x's and range are the y's. If you look at the table, all your x's, so 54, 65, 50, those are all here on the x's. On the left side, sorry. And the y's, so 20, 30, 25, 20, 30, 25 are in the right side, which is your range. So that's all you need to know or understand from this page. And then it does the same thing with other data. So it doesn't have to be numbers. It can be names like it is here. Also, they wanted you to know that when you express domain and range, you express it in form of a set, which is this right here. Okay, so mapping is when you do this example or when you do this process, put them in a circle, write all your domains, which are these, and then write all your range, which are these. Okay, for page 2, they're explaining the rule method, and they're going to use this equation to introduce it, and they're using these coordinates. So the way they got the y's here is by plugging in your own choice of numbers. They're always going to use -1, 0, and 1. So if you see here 0, +1, -1, and then they used 2. So these are always going to be the 3 numbers that you use. You don't have to, but I suggest that you do. So I'm going to show you how they did that. Basically, they did a XY table. So let's go back. So XY table. And what you do is, these are your X's, right? XY. And you're going to plug it into the variable. So you're doing y equals 6 times x. So y equals 6 times, and then you put 0. So 0 times, or 6 times 0 is 0. And then next you're going to plug in 1. 6 times 1 is 6. And then next, -1. 6 times -1 is -6. And then they did 2. So if you plug in 2, 6 times 2 is 12. That's how they got 0, 6, -6, and 12. Okay, and then remember, you're always going to use 1, -1, 0, and 1. So when it's your turn to do them down here, those are going to be the coordinates that you use. But before we get there, they were, for the graphs, you didn't have to do anything on the graphs. I saw that you drew like a line somewhere around here. They just wanted to show you the difference between this kind of equation and an equation that has x squared. They just wanted to point out to you that since it has x squared, the numbers are going to be positive, because any negative number squared is a positive number. So that's all they wanted to show you for that. Now, down here, go back for a second. I want you to write something. Oh, no. Okay, we're not there yet. Okay. So here, your domain and range, again, is your X and Y. So X, Y, X, Y. So you're going to write in a set notation, which are those little bracket things. My X's go on my domain. So 3 and 4. And your Y's go over here. So 9 and 8. Okay. For this one, same thing. X, Y, X, Y. So go ahead and you can do that one. This one just has one X and one Y. So just write them, your X here and Y on the R. For number 2, you're going to do an XY table. And we're going to use -1, 0, and 1. And we're plugging it in for X. So 2 times -1 equals -2. 2 times 0 is 0. And then 2 times +1 is +2. So for your domain, you're going to write -1, 0, 1, which are these. And then your range are these, which are your Y's. So -2, 0, 2. Okay. For number 4, you're going to do an XY table again. XY table, 1, 0, or sorry, -1, 0, +1. So again, you're going to do 2 times, plug in your X, and then add 1. So I'm only going to do the first one for you. So -1. 2 times -1 is -2. Plus 1 is -1. Okay, so you can go ahead and plug in 0 and 1 to get your other Y's, but your domain is going to be -1, 0, 1. And then I did the first one for you. So -1. And you have to go ahead and find those two, the other two. For number 6, since it's absolute value, the inside is, or the answer is always going to be positive. So again, we're still going to use -1, 0, and 1. But if you plug in -1 or any negative number, the rule is the bars drop and so does the negative sign. So it becomes +1. And then if you plug in a positive number, then it's going to stay positive. So if I plug in 0, the answer is 0. If I plug in 1, the answer is 1. The only answers that change is when it's a negative number. So again, if it's like a -3 that you plug in, the answer is going to be +3 because you just dropped the negative sign. So for that one, number 6, -1, 0, 1, and then 1, 0, 1. Okay. And then for number 7, again, just plug in -1, 0, and 1 and subtract 1. So for number 8, it's the only one that's different. Your formula is supposed to be Y equals number here plus or minus, or sorry, no, X goes here and then plus or minus a number. So if you look at the example on top, Y, X, and then number. So that's what it's supposed to look like. So for this one, x is on the wrong side. So we have to move this over. And you do that by doing the opposite. So this is positive x, so we're doing minus x on both sides. So now we've got negative 1 equals 0, or sorry, negative x plus 0. And then there's an invisible 1 here and here. So you're going to divide by negative 1 to cancel. Divide by negative 1 and then divide by negative 1. So your answer is going to be y equals positive 1x plus 0, because anything with 0 on top is going to be equal to 0. So this is your formula, and then you're going to go ahead and plug in negative 1, 0, and 1 for these. So your domain for that one will be negative 1, 0, and 1. And then when you plug in, you'll find your range. So number 3, 5, 7. So you can do those. Okay. And then on this page, all you need to know for function is, in order for it to be a function, x cannot repeat. Okay, so if you look at these ordered pairs, these are two separate sets of ordered pairs, and you're only going to look at the x value. So x, 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 and then x. Okay, so for the first one, this is called relation x and relation y. So for relation x, which is this one, do you see any x's more than once? Are any x's repeating? So we've got negative 3, negative 1, 9, and 0. So no, there isn't any repeating. So yes, this is a function. For relation y, are there any x's repeating? 0, 1, negative 4, 0. 0 repeats, which means not a function. Okay, not a function. So sorry, the screen is like jittering. So again, to recap, x cannot repeat. So here they're showing you in set notation for relation x. It's showing you that negative 3 is going to 3, negative 1 is going to 2, 9 is going to 1, and 0 is going to 3. So they want to confuse you because you're seeing two numbers, which is negative 3 and 0, going to positive 3. But the rule is x cannot repeat. So your domain, it doesn't matter if y repeats. Okay, and then if you graph, so it said relation y, which is this one, is the one that is not a function. So if we were to put these on a number line, or not a graph, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. So I'm gonna graph 0, 0, which are these right here, the ones that are not a function, the blue up here. These, I'm graphing these. So 1 and 4, -4 and 3, 0 and 2. So -0, 0 is right here. 1, 4. So 1, 1, 2, 3, 4. We've got -4. So 1, 2, -4. And then 1, 2, 3. And then we've got 0 and 1, 2. So by looking at a graph, how do we know if it's a function? They want you to do a vertical line test, which you're going to see on the next page. But basically, it's when you throw a line going down the dots that you made, like that. So this one only has one dot. This one only has one dot, but the one in the middle has two dots, which means it's not a function. That's how you know it's not a function. So if we look at the next page, it explains it right here. So we've got coordinates, coordinate, coordinate, and then they're doing their vertical line test. So line, line, line. So each line only has one dot, one dot, one dot. So yes, this is a function. If we look at this one, we've got two dots on one line, two dots on one line, two dots on one line. So no, no function. And that's called the vertical line test. Vertical line test. So they gave you these. Again, if you just look at the x's, are any repeating? 0, 4, -1. No repetition means yes, function. Okay, if we look at this, they want to trick you because you're not seeing 3 2 times here, but 3 has 2 lines coming out from it. So no, not a function. You can also look up here, 3, 2, 3. The 3 is repeating. So no function. And this right here, again, this is called mapping, which is what they want you to do down here. It says using the appropriate test, determine whether each relation is a function or not. So for me, all you need to do is look at the x's, and if they repeat, then no. If they don't repeat, then it is a function. But for Miss Maria, you want to make sure that you do this. Write your x's in here and your ranges in here, just so she can see that you did it, or do it on a graph and do the graphing, the line test, which is this up here, because it says to do the appropriate test. But just looking at my x's, 0, -1, and 3, no repetition. So yes, this is a function because there's no repeating x's. And 0, 4, 0, 0, 0, repeating. So no, no function. Okay, you can do those 3. So again, if my x's repeat, no function. If there's no repeating, then yes, function. Okay, so you can go ahead and do 2, 3, and 4. And then don't forget to do your mapping test or the graph. For these, It hits here, 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 and here. But they're trying to trick you. If you throw a vertical line test, throw your line, each dot only hits one time. So yes, function. For the second one, we've got one here, one here, one here, and one here. That one's good because it just has one. That one's good because it just has one, but the one in the middle has two, so no function.